Tutorial of LeetCode question number 80, where we have to remove the duplicates from the sorted array. So this is the medium version of this problem. We will see what are the constraints and what we have to do in this problem. So as question is very simple, question statement is very simple, that we have to remove the duplicates. Suppose 1 1 1 2 2 3 3 4 5 6 is given. So if you will see this, according to question, array given is in non-descending order. Non-descending order means it is sorted, but it may contains duplicates. Now, according to question, we have to remove the duplicates, that's for sure, but we can keep at most 2 element. So if we will see this example, then our answer here will be, we can keep this one, okay, we can keep this one also, but we have to remove this one, because at most we can keep 2 elements of a number. So this 2 we can keep, this also we can keep, but we have to remove this. This 3 we can keep, this 3 we can keep, 4 5 6. So for this array, for this input array, this is my answer after removing the duplicates. Now, question description, if you will read, it's very lengthy, so I will try to summarize it. Suppose if we will take this array only, so as we know that we cannot change the length of the array. So if we cannot change the length of the array, then how we can remove the duplicates? So how we can remove the duplicates, and according to question, we have to solve it in space complexity of big O of 1s, means that we are not allowed to use extra space. Now how to solve this problem means what we have to do. So we have to, if you will see the question function, we have to return k value. So if you will ask what is this k value, this k value is nothing but length, or instead of, we can say number of elements after removing duplicates, and these duplicates we are removing according to question. So in this array, in this example, our k value will be 1 2 3 4 5 6 7 8 9. So in this our k value will be 9. So this is the input array, right? So we have to modify this input array only up to k is equal to 9. So how we can do this? So what we can do is, we have to replace this 1 by 2. This 2 is at correct place. This 2 we have to replace by 3. This 2 we have to again replace by 3. This we have to replace by 4. This we have to replace by 5. This we have to replace by 6. So if they have to compare, they will compare only these k elements, which is equal to 9. These two elements are useless, they will not compare this. So according to this only we have to change our input array. So I hope this is clear for you all, that what is the question and what is k value which we have to return, and we have to modify the given input array only. Now let's come back to the question. If we have to solve this question, so if we will first talk about brute force, brute force approach will be pretty simple. It will be, we can calculate frequency of each element, and according to, if we calculate the frequency of each element, if I will talk here, so frequency of each element will be, for 1 frequency will be 3. If we will take the input array, for 2 frequency will be 3, for 3 frequency will be 2, for 4 it is 1, for 5 it is 1, for 6 it is 1. So if we know this frequency, then the given input array we can fill in the same way. So for 1 I will take only 2 elements. If it is greater than 2, we will discard it and we will take only 2 elements. Now for 2, it is again greater than 2, so we will discard and we will take only 2 elements and we will fill here. For 3 it is 2, so it is perfect, we will take 3. For 4 I will take 1 element, so that is perfect, we can take it. For 5 frequency is 1, so perfect, we can take it. 6 frequency is 1, perfect, we can take it. Rest element we will keep as it is. So we have modified the input array only, that is for sure, but we have used here extra space. Here we have used extra space. So in this way we cannot use, as according to question we have to say this in the constant space. So if you will talk about time complexity also for this brute force approach, so time complexity will be, first we have to iterate on n elements for this to maintain the frequency array. Then can I say that again you have to iterate on this and fill this, so maximum worst case it will be n only. So in this case time complexity will be 2n. And if we will talk about space complexity also, in worst case it will be n. Why it will be n? Assume every element is unique, so every element once it will get entered here and once again it will be updated in the array. So in worst case space complexity will be also n, but according to question we have to solve it in constant space. Now let's see the optimized version of this. So if we have to take the example, let's take an example of 0 0 1 1 1 2 2. Let's take this example. So first write its indexes. So if we have to write its answer manually, so can I say that its answer will be 0 0 1 1 2 2 3 3. So indexes we are using is 0 1 2 3 4 5 6 7, and 8 and 9 we are not bothering, and k value here will be 8 because we have total 8 elements for which we are bothering. So how we can solve this problem? If we will see this, it's for sure that we have to, means we can allow at least 2 duplicates, right? We can allow at least 2 duplicates. So can I say that we have to start from here, from this index, because whatever the elements are here, means if there are only 2 elements, if they are same also, we are not bothering about those 2 elements, because we can at least at most we can keep 2 elements. Now let's take a case where, let's take this case. Now if we are starting from here, as we know that array is already sorted, and if we are starting from here and if this element and this element are same, means that we are going -2 times -2 from this index and we are comparing this and this. If these two are same, can I say that its frequency of this element is greater than 2? Because we are going 2 times back and comparing these two elements, and if those are same, so its frequency is greater than 2 and we have to remove this element. Yes, right? So we can use the same approach here also. Let's see how we can use this. So first I will iterate in the simple manner. So let's take L here, let's take R here. Now these two elements are different, so it's okay. What we can do is we will move both our pointers. L will move here, R will move here. Again minus 2, these two are different, so okay, no problem in that. Again we will move, this is my L, this is my R. Suppose there is a way, suppose if we will take list only in a Java, we will take where we can remove the elements, so its indexing becomes less. Suppose if we have that facility where we can remove the element, so if we compare these two elements are same, so can I say that I will directly remove this element? If I will directly remove this element, then my L and R pointer will move here. If it is a list, we can directly remove this. So my L and R will move here. Again, I will compare with minus 2 element. Both are different. Okay, no problem. L and R will move here. Okay, again same, no problem. Or instead of this two pointer, you can take one pointer also, no problem in that. Why I am taking two pointer is it will be helpful for the next approach. Again no problem here, so again here we will check, no problem. Here we will check, no problem. Here if we will check these two element are same again. So what I can do is I can directly remove this element. So this is the way, if there is a facility, if there is any data structure which helps us to remove the element, so we can do this. And in Java you can achieve this by list, where you can directly use list.remove function which take index as the parameter. Now let's move forward, and it is given as array, so we have to work on the array only. So now this time what we will do is again we will iterate on the same input, and let's check how we will iterate on this. We will take two pointer, as you all know, that means it's for sure we have to take L and R. Now what is the meaning of L? What is the meaning of R? So I will write here the meaning of L and R. L means index which we have to correct. R means index which will send element or send correct element to index L. So it will be clear more if we will move forward. So let's move forward. Check here, is my L minus element at L minus 2 is equal to R? No, it is not equal. So we know that means if it is not equal, it is correct. So what we are condition we are checking? We are checking this condition a of L minus 2 double equals to a of R or not. If it is the case, then we are in trouble. Means that there is a frequency, means there is a element whose frequency is more than 2. So here we have no any problem, right? So what we can do is we can move from here. What we will do? We will move from here. How to move from here? We will directly move here at this place. So if we will move here, this will be my L pointer. This is my L pointer, and where will be my R pointer at this time? So R will be also at this place. Now again we will check by L minus 2. If we will check L minus 2, this is the element L minus 2. Is it equal to R? No, it is not equal, means we are safe. So we will again move this pointer here. This is my L, this is my R. Now this time if we will check a of L minus 2, it is double equals to a of R, means we are in trouble this time, because if these two elements are same, means that its frequency is greater than 2, then what we have to do? We have to remove some element. So we have to replace this one, right? So L is the index which we have to correct. So L will be here and R will move in this case. So R will move here. Now if R will move here, we will check, is two elements same? R and L minus 2 same? No, it is not same, means both are not same. If both are not same, so can I say that at place of 1 we can replace 2? So this 2 will move here, and if you will check this original also, the answer which we wrote manually at index 4, we have 2. So if it will move here, so can I say that R is already done, R will move here, this index got replaced, so L will move here. So this is our correct place. Now this is our 2. If you will see here, the frequency of 2 has increased, but there is no problem in that, because it will go in the garbage place. This garbage place which we have means after removing the duplicate. So once check the complete iteration, then you will understand this. Now again check L minus 2 and R. If you will check these two, L minus 2 and R, okay, both are same, both are sorry different, so no problem we have. So we can move our R, we can move our L. Again if you will see, so here what we have done, we have swapped, means we have done A of R, sorry, A of L is equal to A of R. Again come to L minus 2, this is the L minus 2, this is the R. Now both are different. If both are different, means that something we have changed and we have to again swap, replace it. So can I say that these two will become 3? So if you will see in the answer also, this is the case, and in this case R will move here, L will move here. So this is the correct location of this is 3 and this is our L. Now again check for this 2. Again L minus 2 is 2. L minus 2 is 2. Now if you will see here what we got, the extra 2, it got replaced by 3. Now again check here, it is 2 and 3, L minus 2 is 2 and R both are again not same. So can I say that again we have to replace, so this time it will got replaced by 3 only, and R will move here, L will move here. Now again we will check this. If we will check this again, so if you will check here, again both are same. So if you will come here, L, this and this are same, so we will not do anything, we will move R to find it replacement, and as R is crossing, we are done. So can I say that up to index number 8 we have changed, we have replaced these values? So L is where? L is at index number 8. So can I say that up to index number 8 we have replaced, means that all these elements we have correct position, means all these elements we have checked and all these elements are at the correct place. So can I say that all these elements are correct and after this we don't know anything? So total how many elements are there? So can I say that 1 2 3 4 5 6 7 8, which is nothing but L value. So total L value, L elements are at correct place, which is nothing but our K. So I hope you all able to understand this example. So if we have to code this, how we can code? So to code this, it's pretty simple, because we know that from L and R where we are starting. So we are starting our L with 2, and if you will see here, every time we are moving our R pointer, every time it is continuously moving, so instead if it is continuously moving, so can I take a for loop for int R is equal to 2, because R is also starting with 2, R is less than n and R plus plus. Now if it is the case, we know this is the only case where we have done this case. So can I say if my array of R not equal to a of L minus 2, if it is not the case, then we are swapping. So what not we are swapping, we are replacing. So how we are replacing? We are at a of L, we are keeping a of R, and we are doing R plus plus, sorry, L plus plus, because this element we already corrected, and after correcting this we are moving our L pointer. Now after correcting this means we are done, and we will close this for loop. As R is always moving and L is only moving when we are correcting it, you have already seen here when we came here, L pointer, when we came at this place, L pointer is stopped here. When I becomes 3, L pointer is stopped here and R pointer was moving. So if we have to analyze the time complexity for this case, so can I say that time complexity is only big O of n, because only one time we have iterated on the array, and the space complexity wise we have not used any extra space, so space complexity is big O of 1. So I hope you all able to understand this. And okay, we forgot one thing. After this we have to return L value, which is nothing but our k. So I hope you all able to understand this video, and it will allow you to solve this problem. Okay all, see you all in the next video. Bye bye.